Welcome dear civil engineering viewers and students. So today we will be solving a cantilever beam subjected to load at the free end, and in which we will be able to find out the deflection. The deflection is found using conjugate beam method. Now here a table is given in which the left hand side you have the real beam, and in the right hand side you have the conjugate beam. So here let us take this case only, where you have got a cantilever beam fixed at end A and free at end B. The equivalent conjugate beam shows you that the fixed end becomes free and the free end becomes fixed. So this is the conjugate beam, and in other things you can see that the simply supported beam, the support conditions remain the same. So today we will see how to solve this cantilever beam. So this beam is taken today as an example, and we will try to solve using the conjugate beam when it is subjected to a load P at the free end. We will try to evaluate the deflection delta at the free end. Now the theory on conjugate beam denotes that the slope at the support of real beam is equal to shear force at the location of the conjugate beam. Then deflection at the location of the real beam is equal to moment at the location of the conjugate beam. Remember that S stands for slope and S stands for shear. So slope at the support of real beam is equivalent to shear force at the location of the conjugate beam. Find the deflection at the free end of the conjugate cantilever beam. Use conjugate beam method. So here a load P is applied. Let us take that this fixed end is A and keep the free end as B. The length of the beam is L. As you see here, the length of the cantilever beam is L. So this is a real beam. This beam is a real beam. So obviously you are going to convert this cantilever beam into conjugate beam. So here you can see that the free end has become fixed at this location and fixed end has become free at this location. So you can see that the fixed end becomes free and free end becomes fixed, and this beam is said to be conjugate beam. Now this is the equivalent conjugate beam to the cantilever beam considered. We are going to calculate the deflection at the free end. So here we are going to calculate what is the deflection. So delta has to be calculated. So what is this delta? This delta is nothing but it is related to the moment developed at the conjugate beam. So this moment is equivalent to the delta. So this M and delta are related. So the deflection at the free end of the cantilever beam is equal to moment developed at the fixed end of the conjugate beam. So this is the bending moment diagram. First of all, we have to draw the bending moment diagram for the real beam, and you divide it by the flexural rigidity EI. So this PL by EI diagram is drawn first. Then this PL by EI diagram becomes the load diagram for conjugate beam. So this is the load dia for the conjugate beam. Load dia for conjugate beam. CB represents conjugate beam. So next slide you can see that this is the real beam and this is the conjugate beam, where you have A and B here and the length is L. Now this is applied as loading here. The triangular loading is nothing but the bending moment diagram for the real beam is taken to be the load diagram for the conjugate beam. So from here you have calculated the bending moment diagram for the real beam, and it is being shifted to the conjugate beam as load diagram. For this load diagram you have to calculate what is the moment at the fixed end for the conjugate beam. Now here again you can see the conjugate beam loaded with the bending moment diagram, that is bending moment diagram of the real beam. So like this you are applying the triangular loading. So here it is nothing but at the end you have PL by EI. Now here in conjugate beam you have to calculate the moment. So how to calculate the moment? Moment at the conjugate beam at point B equal to the total load. The total load is half into the length is L length multiplied by the, here you have PL by EI. So you multiply this by PL by EI. This forms the total load. So this is the total load as you see. Then the moment is nothing but the total load multiplied by the lever arm distance. So lever arm distance is nothing but the centroidal distance. As you see, the centroid is located here. It is just 2L by 3 from the 0 point of loading. So multiply it by 2L by 3, which is nothing but the lever arm distance. So this is lever arm. So on multiplying this, you are getting here PL cube divided by 3A. So I have found out the moment at point B. So now you can relate this moment with deflection. Deflection at the free end of the cantilever due to point load is nothing but it is PL by 3I. So here the calculations are explained. Again, deflection at the real beam B equal to moment at B of the conjugate beam, that is equal to half into PL by EI times L multiplied by 2L by 3, and finally you get PL by 3 cube, which is nothing but delta of the real beam. So here deflection at the real beam B equal to moment at B of the conjugate beam, that is equal to PL by 3A. This is how we find out the deflection at the free end of the cantilever. If you have any doubts or you mention in the comments, please subscribe to the channel. Thanks a lot for watching.